Welcome back. This is Anthony from Embrace Tutoring and Educational Services, and we're going to get started going over the SAT Math Practice Test 1 questions 1 through 10. All right, so here we go. Let's get started. So it says for question 1, if x minus 1 over 3 equals k, so x minus 1 over 3 equals k, and it says if k equals 3, what is the value of x? So if I know that k equals 3, then I can essentially plug that in for this. So x minus 1 over 3 equals 3. And it says, what is the value of x? So I'm going to want to end up isolating to solve for x. Now, I know that algebraically that if x minus 1 over 3, I want to end up eliminating this fraction in some way. Now, I can either cross multiply or I can simply multiply by the reciprocal. But either way, I'm going to end up getting the 3 over something of say 1 over 3 or 3 over anything n3, I'm going to end up canceling out the 3. So I'm going to end up getting x minus 1 equals 9. Now, in order to isolate and get x by itself, this is going to be a positive 1 here, or add 1. Then I'm going to end up getting x equals 10. Solve it through, and that is answer choice D. Great. Let's move on. All right, question 2. It says, for I equals radical negative 1, what is the sum, I like that, 7 plus 3i plus negative 8 plus 9i. Now, if I have, so here I see that this is going to be 7 plus 3i, and I'll put these in parentheses initially. But I really like the fact that this is a positive sign and not a negative. Otherwise, I'd have to distribute the negative across. This is plus negative 8 plus 9i. Now, because these are all addition, then I can actually simplify this and basically just add like terms. All right, I'm not multiplying this. I'm not also carrying through the distribution. So this just becomes 7 plus 3i plus, and I'll keep the plus there, that way you guys can see it. And then this is negative 8 plus 9i. Now, I want to combine these like terms. So I'm going to put little squiggles under the i's for you. Okay, so here's the 3i and then the 9i. So this is going to be plus 12i altogether. And then I have 7, and then I have plus negative 8. So 7 and negative 8, right? Here we are, what they have. So 7 plus negative 8 is negative 1. So this is going to be negative 1 plus 12i, or your answer might also appear such as, 12i minus 1, and this. This could be my best answer. All right. So let's see. Let's move on up. Question 3. All right, question 3 says, on Saturday afternoon, Armand sent M text messages each hour for 5 hours. So Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Okay, so I see here that both of these are within an each hour increment, which is good to know, and both are also within hours. It says, which of the following represents the total number of messages sent by Armand and Tyrone? Now, I like this because I'm immediately thinking total and the word and are big hints. And that's telling me that usually when you see the word and, usually it's going to denote an addition sign, and it's also saying total number of messages sent by Armand. Both are in the same increment or in the same unit in terms of each hour, right? So text messages per hour over a certain amount of hours. And in this case, Armand is going to send M text messages for 5 hours. So Armand is going to be 5M. And now it's going to be total number of messages, which equals, let's just say this equals like a certain amount of whatever the total messages they are. But you're adding these together because it's the amount that Armand sent and the amount that Tyrone sent. And Tyrone's going to send P messages in the amount of 4 hours. So 5M plus 4P is going to end up being the total that they sent. So C is going to be your best answer. All right. All right. Question 4. Question 4 states, I'll do some work over here, that way it kind of makes it easier for you guys. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has to fix at the end of each week, okay, or at the end of each day can be estimated with the equation P equals 108 minus 23D. All right, it tells me where P is the number of phones left. All right, so P is the total amount of phones left for that particular week. They don't specifically say what 108 is, and it says, oh, okay, so what is the meaning of the value 108 in this equation? And then it says D is the number of days she has worked in that particular week. So D is the amount of days. Also notice the subtraction sign. What that's saying is that P is the amount of phones that she has left in the entire week, the amount of phones that she has left. And D is the amount of days that she's worked, and I'm guessing 23 is about the number of phones that she gets to that day, like every single day. Well, assuming that, right, P is the amount of phones that she has left throughout the entire week, right, 108 isn't clearly identified, and that's what they want you to rationalize. What is the meaning of the value 108 in this equation? And, right, 23D. Well, let's assume that she didn't work at all. Right, let's assume D equals 0. Maybe she took a vacation, right, for whatever reason. Maybe Kathy just needed some time away. So P equals 108 minus 23, and she didn't work, right? So she didn't go to work, 0, right? 108 minus 23 times 0 equals 0. Well then, assuming she didn't go to work at all, then P equals 108. Now, this is the amount of phones that she has left. That's what P represents. But if she didn't go to work at all, then, if she didn't go to work at all, then she wasn't able to accomplish any of the handling the phones. So this must be what she actually starts with. And the negative, or the subtraction sign, is also showing you that she's taking away from a certain total per day. So your answer should reflect the fact of something that she's starting with, knowing that if she doesn't work at all, this is the amount that she has left or remaining. And it says Kathy will complete the repairs within 108 days. Not the case. Kathy starts each week with 108 phones to fix. Yes, good. Kathy repairs phones at a rate of 108 per hour. Nope, she'd be hardcore. Kathy repairs phones at a rate of 108 per day. Nope. All right, so B is your best answer. Great. Let's move on. Okay. Question 5. Okay, so whenever you see expressive equations such as this, the general hint that I'll tell you is that, one, watch out for the negative or the positive sign here. What you need to be aware of is that because of the fact that this is negative on the outside of a parenthesis, that you're going to have to actually distribute this across to each of the terms within the parenthesis, right? It's a common understanding that the SAT is definitely going to evaluate you on often, but it's something if you can't do, you're going to seem to struggle with more and more of these types of questions. So the first is make sure that you are aware that this is negative to a negative becomes a positive to a positive becomes a negative, right? Negative to a negative becomes a positive. The second is you want to take a quick glance at your answer choices to see really what they have. And I'm noticing that a lot of these are using the y squared. And that's probably because if you end up doing this incorrectly with the distribution, they're going to assume that you're probably going to subtract or add really when you should do one versus the other. So let's get started. Here you have x squared y minus 3y squared plus 5xy squared. Now I'm going to get ready to distribute this. So this is going to become a positive, and then this is then going to become a positive as well. Negative to a negative becomes a positive, and this is going to become x squared y. And negative to a positive becomes a negative, so 3x y squared. Negative to a negative becomes a positive, so this then becomes 3y squared. Now, I see what I have here, and I'm going to want to combine like terms. But I'm going to combine like terms based upon like what's the fastest way to do my answer choices. I can immediately see that something with the x squared y that I see here, something with the x squared y, so this is positive, that's positive. I'm going to add these together, 2x squared y, good. If anything doesn't have that in my answer choices, I'm gone. Now, what's the difference between C and D? I'm going to look for the y squared, right? I'm going to look at whether or not you have to add these or subtract these out. So I see here minus 3y squared, and here I see positive 3y squared. So these are actually going to cancel themselves out. Now, if you got the distribution wrong, then you would actually, this would be a negative, and therefore you would choose D, and that would be wrong. But instead, you want to choose C, because even if we kept going with the rest of the problem, you would see the 5xy squared minus the 3xy squared is actually going to end up giving you the 2xy squared. So altogether, this is your answer choice, and C is your answer. All right. All right, question 6. A pediatrician uses the model above to estimate the height of a boy. Okay, so the height of a boy, H in inches in terms of the boy's age, A in years between the ages of 2 and 5. Okay, so I see that there are going to be increments. Okay, so between the ages of 2 and 5 means 2, 3, 4, 5. Okay, based on the model, what is the estimated increase in the boy's inches of height each year? All right, now this problem seems more complicated than what it is, but really what they're saying is, well, if the boy's, let's say the age equals 2, right, versus his age equals 3. Well, this is the equation that they're using. So his total height is going to be his age, and the 3 is the rate at which he's growing plus this incremental value here. So here we have, let's say the total height when the boy is 2, I'm going to have 3 times what's my age? Well, my age at this point is 2, right? Plus 28.6. So here I'm going to have 6 plus 28.6. That's going to give me 34.6. Instead here, when he turns 3, now what we're really going to want to do is we're going to want to figure out the difference, right? We're going to want to figure out the difference of how much did he grow when he was age 2, right? This is total height here in inches of age 2 versus what is his total height here when he was 3. So his total height when he was 3, right, we're going to have to plug in the 3 value for his age, and then plus the 28.6. So here I'm going to have 9 plus 28.6. I'm going to end up 9 plus 28.6 is going to be 37.6. We can see the difference between 37.6 and 34.6 is going to be 3, right? Now, I chose 2 and 3 purposely because I know that they have to go, right, 2, 3, 4, 5, right? I know they have to go in incremental values. So I didn't do 4 and 5 or 3 and 4 because I just chose the 2 smalls to make it a little bit easier on myself rather than choosing the harder numbers, right, or 4 and 5, right? Hard is relative, but choose the smaller numbers first. That way you can essentially do the calculations faster. You'll notice that if you did the 4 and 5 here for age equals 4 compared to age equals 5, you'll still notice the incremental increase per year is going to be 3. But choosing numbers wisely is also just as important. Okay, so question 7. Okay, all right. Question 7 does not look fun. Let's just put it that way. Question 7. So, question 7 says the formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months. Which of the following gives P in terms of M and R? So my biggest hint here is this wording. It says which of the following gives P in terms of M, R, and N. So I'm now going to glance back to this equation, now knowing that I want to find P, right? Whenever you have an expression that says which of the following gives P, that means that all of your answers should be P equals something, and then you should have the other variables over here within the other side of the expression. So which of the following gives P, so P equals, right, in terms of M, R, and N. So my M, R, and N should be over here somewhere. I don't know where, I don't know how they're going to be set up, but I just know that I want P equals something. And now I'm gonna glance back at my equation up here. Okay, so I see that initially they have M over here. I also see that the R and the N are both within the fractions as well as the exponent form on both sides of the fraction. And then I see I have P over here, right, just hanging out. Now, This actually seems more complicated than what it is, or at face value it looks pretty complicated. But what you see is that you have like one large fraction here, right? You have an m equals, you have a really complicated looking fraction, and then you have p. But imagine if we did something where it was, let's say m equals, and let's just say 1/2, right? Let's say m equals 1/2 p. Now, in order for me to get rid of this fraction, I would still have to do the same thing. I would still have to multiply by the reciprocal for both sides, right? So I would still have to end up doing 2/1, right? 2/1. I would then cancel out my 2's. So, and then this over here would actually be 2m equals p in some way. Notice I just solved in terms of p, and I have my other variable still on the other side of the equation. But here's the true hint, is that by multiplying by my reciprocal, I have this 2 and essentially flips up. Now, initially, my 2, like if I do this, my 2 was a denominator, if you notice that. But more importantly, when I flip this up, it then became a numerator. So if I have the 2 in the denominator, but it flips up by the reciprocal, then my numerator should appear within my answer, right, in the top of the actual expression. So this could still be 2/1, right? You can easily put that. But notice it's still a numerator over here, and here I have my p. Now, if I go back to this complicated expression, what that tells me is that this bottom, right, this complicated expression here, the denominator, more precisely, if I multiply by the reciprocal, this then should appear on the top, right? As if I were to take this 1 plus r over 1200 to the n power minus 1, that should then appear, just like the 2 down here, of it being the denominator flipping over to the numerator, that should then appear in the reciprocal on the other side of the equation. Well, luckily for you, there's only one answer choice that really does that. And if I were to, let's just say, scroll down real fast. Okay, so let's look at some of my answer choices. I have, so here I want to find the 1 plus r over 1200, right, the minus 1. Don't get confused by the minus 1 and the plus 1. I immediately know it's not C or D because it's not in a fraction form. And it's actually going to be B. And the reason why it's B, just like we stated, is that because this is the expression I'm looking for to be in the numerator, and there's only one possible answer choice. So B is your best possible answer. All right, let's slide down. It says if A over B equals 2, all right, so if A over B equals 2, what is the value of 4B over A? So what I want to find is 4b over a equals question mark. So what I'm attempting to figure out is how do I get this information here in order to solve for that information there. And well, what do they have in common, right? Here I have a over b equals 2, here I have b over a. Now think to yourself, if this is a proportion, if I have a over b equals 2, then this is really a over b equals 2/1. Now, what do you think is going to happen if I have b over a? What do you think I would do with this proportion? Well, this would then become 1/2, right? If I have a over b equals 2/1, then b over a equals 1/2. Well, how do I make b over a equal 4b over a, right? How do I make b over a equal 4b over a? Well, I could simply multiply, right, this entire side of the equation in order to get 4b over a. But remember, whatever you do to one side of the equation, you also have to do to the other side of the equation. So if I ended up getting 4b over a, which very well is the case, right, 4b over a, then this is going to equal to 1/2 times 4. And so 1/2 times 4 is, right, 4b over a. It's going to end up giving me 2. All right, and C is my answer choice. Great. So it looks like the next equation is going to be a system. Yeah, next question is going to be system of linear equations. The idea behind system of linear equations is that, one, you always want to attempt to do elimination. It's just far faster rather than having to plug things in terms of the substitution method. And then two, you want to quickly glance at your answer choices to see which one you should try and solve for first. I see here that I have two possible choices that are the same for y. So I actually want to try and solve for x, right? Because here I have 4 different possible answer choices for x. Sorry. So since I have 4 different possible answer choices for x, the goal is for me to eliminate y. And if I want to eliminate y in order to solve for x, then I want to try and figure out, well, which of these equations can I use in order to eliminate y? And it seems as though the bottom equation, if I were to multiply this by 2, this could then allow me to make this 4y and subtract this out. So I can eventually get 4y minus 4y and cancel them when I subtract out both of the equations together. So I'm going to have my 3x plus 4y equals negative 23. And that's still going to stay on my top equation. Now my bottom equation I'm going to rearrange to make it a little bit easier. So I'm going to have my positive 4y, and here I'm still going to do 2 times negative 19 is going to be negative 38. Cool. 2 times negative x is going to be negative 2x. Now, once again, the whole point behind this, and really the strategy, is I want to try and subtract this equation here from my top equation. And the idea is that I'm trying to solve for x, because each x is a different answer choice rather than my y's, where if I end up solving for negative 6, I still have to solve for x anyway, right? So here I have my 4y minus my 4y, and then, right, so those would cancel. Here I have my 3x minus my 2x, and remember, if it's let's say, we'll do this quickly down here, right, 3x minus negative 2x, this actually becomes positive like that. Negative of negative becomes positive. So here I have my 5x, and here I have negative 23 minus negative 38. This becomes, right, positive, positive. Negative 23 plus 38. This is going to equal 15. If I were to isolate to solve for x, I have 5x equals 15. Here's 5. Right, divide by 5, divide by 5. X equals 3. And luckily, well, okay, good news. I, right, was solving for x, right? That's why I care about here. So x equals 3. B is my answer. But let's assume that I ended up, if I would have solved for y, I would have ended up getting the right answer choice anyway. But let's just assume you want to plug this back into y to check. So I'm going to bring this back up, and I'm going to plug it back into the equation. So here I have 2y minus x equals negative 19. Now here I have my 2y minus 3 equals negative 19. If I were to add the 3, right, this is going to be negative 16. This is 2y, and I'm going to get y equals negative 8. And my answer choice does work. Question 10. So question 10 is asking me, it says for the function g defined above, a is a constant and g of 4 equals 8. Well, whenever I see g of, let's say, something equals something, whenever I see this g of something, that's actually referring to y. And now the value that's inside of here, like say for instance I have like g of x, that g of x is something equals y. Now that value that's inside of here is the actual x value. So this is going to be x equals 4, right? Let's just simplify it. X equals 4 when y equals 8, right? Or y equals 8 when x equals 4. So if I had the equation g of x equals ax squared plus 24, I know that when x equals 4, y equals 8. So I can plug this in here for y equals, or g of x, or g of 4 in this case, and I know that a is a constant, and g of 4 equals 8. I'm going to be able to take this 4 and plug it in for x. So I'm going to take the 4 here, put the square, and I'm going to put 24. Now, I'm going to sort of quickly identify for the function g of defined above, a is a constant, g of 4, what is the value of g of the negative 4? Well, what that means is that I can take this value for a, and I can plug this back in to the other equation, which I'm going to want to solve for. So g of negative 4, right? And I don't know what that is, but I know it's the same equation essentially. I know that it's g of negative 4 equals a of x squared plus 24. And I also know, there's an equal sign, and I also know that my g of -4 equals, well, I can solve for this a because it's a constant, and that a can be plugged in to the other a. And then I know that this -4 is representing, well, this is what when x is -4, right? So plus 24. So the real trick is, can I figure out, to solve for a, and then basically just plug it into the next equation. So here, so let's go back. If I have a equals a times 4 squared, so this is 16a plus 24 equals 8, right? 8 equals 16a plus 24. I can subtract 24 from both sides. Subtract 24. You can probably tell that this is going to be -16 equals 16a, and then therefore a is going to equal -1. Okay, that's great. I'm now going to take this, right, for a equals -1. I'm going to plug it in over here, right? So there's my a, there's my -1, here's my -4. Where did I get that from? From the equation. It says, what is the value of g of -4? Well, that -4 is when an x equals -4. Now I actually want to try and solve for this. So maybe the hardest part is first understanding exactly what you're trying to solve for and how you're going to use a as the constant. And then don't get tripped up with the exponent here. Make sure that you carry this exponent through first to the actual -4, because this is going to become -1. That's separate outside of the exponent. So make sure you do -4 squared, which is going to be 16 plus 24, right? Don't do the negative times that and then square, right? Because you'll get a different value. Instead, do the -4 squared to get 16, then times the negative, which will give you -16 plus 24 altogether. That will end up giving you 8, and 8 should be your answer, and that is. All right, guys, stay tuned for the next video.